Hi, this is Thomas Salvanelli, Cisco Networking Academy instructor at Kuro University. I'm recording this video to explain how switches are selecting a root switch in switch network. There was a question, one of the visitors asked me to explain how switches are selecting a root switch. To explain this topic, I'll use simple topology with three switches. This is the switch. Okay. Let's call S1, which is connected to another switch, switch 2. Switch 3, and we have topology like the triangle. Okay. Now, here's the question: how those switches are selecting a root switch and which one is the root switch. So once we have spanning tree protocol running in switch network, those switches are starting sending BPDUs to each other. BPDU, bridged protocol data units. Okay, BPDU stands for bridged protocol data unit. So switch 1 sends and receive BPDU from directly connected switches. Okay. And here we have BPDUs. BPD, BPD, BPDU. Okay. So BPDUs, as I said, bridged protocol data contains bridge ID. Inside BPDU, we have bridge ID. Bridge ID. The switches are sending to each other bridge ID. Inside the bridge ID, we have two main values. Okay? Two parts. One is MAC address. And second part is priority number. Okay? So these two values will make bridge ID. Okay? Switches are sending BPDUs to each other, which contains inside we have bridge ID. And inside bridge ID, we have these two values. Now, for simplicity, let's say switch 1 has MAC address 11. Switch 2, 22. Switch 3, let's say 33. MAC address. One and one. Now, we have MAC addresses. What about priority number? In spanning tree protocol, priority number. On all switches, we have default priority number, which is 32,768. Each bridge ID by default will have 32,768. 32,768 and 32,768. Now, if on all switches we have default priority number, tiebreaker here, we have MAC addresses. Yeah, MAC addresses. That switch which has lowest MAC address, that switch will be root switch. So after sending and receiving BPDUs to each other, switches will check who has lowest bridge ID. In this case, in our topology, of course, tiebreaker is MAC address, and switch 1 in this situation will be root switch because switch 1 has lowest MAC address. Okay? This is the way how switches are selecting root switch. But here is nonsense. Let's say in this topology, we have switch 1 old switch, let's say 20 years old switch. And here we have switches, say switch 3 from same brand, right? From Cisco. Okay. And by default, these switches will select oldest switch as a root switch. Nonsense, right? Why we are sending all traffic to that biggest switch if you have latest switch? So in this case, if we have everywhere by default priority number same everywhere, tiebreaker is MAC address, and of course oldest switch will be root switch, but our goal to change the root switch only lowering priority number. And if we want to make, let's say, switch 3 as a root switch, we must make this priority number lower than default priority number. Here is a number. We must subtract from this default. Or we can select priority number 0. Okay. So if we change during the configuration priority number default to 0, that switch always have priority, and that switch always will be switch. Okay. This is the explanation how switches are selecting root switch. Thank you for watching.